braving the crowds and the distractions and the temptations. This session is about accelerating innovation, AI, and data best practices in life sciences. Arguably, this is the core of what this entire conference is about. We could have named the conference what this session is. So you are in the right place, without a doubt. Exactly. My name is Kjell Carlsson, head of AI strategy here at Domino. I host the Data Science Leaders podcast, and I was the industry analyst at Forrester that covered data science, machine learning, and AI. But far more important, we have with us Richard Swakla, the Data-Centric Workloads specialist at NetApp.
Yes.
To go and share what he's seeing as the best practices and the trends that are happening right now in life sciences. But I wanted to start out actually with your title. I have the most nebulous title out there. Strategy and AI, it doesn't get broader than that. You have the most focused, useful, clear title out there in terms of what it is that you're doing. But could you share with us a little bit more about your role and your responsibilities?
Absolutely. I'll give a little bit of background first, as I heard the other speaker, doing. And my interest and passion for data started at a young age. Before I could even play Little League, I could tell you that Jim Rice had 46 home runs, 139 RPIs, 406 total bases, played in all 163 games for the Boston Red Sox in 1970. I can tell you Ron Guidry went 25-3. Thank you. Before I could even play Little League. So I had a passion for baseball and liked how data would represent, what players were doing. Because who could watch 162 games of their favorite team, or any team for that matter? And that continued, that passion for baseball, until I realized I could not hit a curveball. Once they stopped throwing me fastballs and started throwing curveballs, baseball was over for me. So one summer, instead of playing baseball, since I just couldn't hit that breaking pitch, I had taken the statistics from the previous year, and I had modified a statistically based baseball game in order to make it a bit more realistic and update it with the current season. That passion continued for data all the way through graduate school. And when I was doing my MBA, I was teased as the quant, of the group in my MBA class. And until we were doing a project on a certain country, and I had found a correlation between that country's currency and a publicly traded commodity, and showed them, yeah, you could make money on this. I've shown this with 91% accuracy, the correlation here. Then I was no longer laughed about or teased or like, oh, this data thing may have something to that. So at any rate, I work for a company called NetApp, which if you guys are in IT, you probably know of, a 35-year-old Silicon Valley company that focuses on, intelligent data infrastructure. And my focus is, as a technical business consultant for NetApp's largest healthcare and life sciences companies, on their applications, their workloads that have a lot of data, the data-centric workloads, as Kjell was saying. So AI, of course, is the biggest driver of that. And if GPUs are the compute and the engine for it, well, data is the fuel.
Absolutely. I always like that analogy. It's like data isn't the new oil. Data is more like crude oil. It's useless in its raw state. It needs to be going and refined into insights. It needs to be going, those insights need to be going, and the fuel needs to be going. You need an engine to go in and build on this and drive outcomes off of it. But one of the things about your background is it puts you in this wonderful position to see all of the different projects and use cases that organizations are going after. And certainly, both right now as well as when I was an industry analyst, what everybody really wants to know is, what is everybody else doing? What is it that I should be doing? And I would love your thoughts on what are you seeing as the most common, valuable use cases that folks are going after?
Yeah. Well, let's just start off with healthcare and life sciences, in the industry here, that we've got this problem, an aging population, and that by 2050, 25% of the Western world will be age 60 or older. And unfortunately, unlike wine, which I love, health does not get better with age, human health. And I think the statistics show that over 65, you're likely to have one major ailment, or perhaps one or more major ailments, and then healthcare gets much more complicated. Well, so usually business problems, we throw things like time, people, money at it. Problem here is that in the people aspects, by the end of this decade, we'll have about a 10 million personnel shortage of healthcare workers for the current need. Never mind the fact that we've got this aging population that's going to continue to grow. Couple that with the fact that in terms of investment in it, in the US, I think it's about 17% of gross domestic product is healthcare spending. It's less in Europe, it's about 10%. But it's a lot, and it's not sustainable, and it's not keeping up. So largely what I see the AI use cases trending toward are things that help productivity. And that matters, it depends where you are in this cycle of healthcare. If you're a payer provider, and I don't think there are any in the room, but the payers do have a lot of say in healthcare spend because they're the ones that do the reimbursements. A lot of their focus on AI is about claims processing, fraud detection, looking for within the healthcare networks of who are most efficient, how they can optimize those networks. Within other parts of healthcare, there's significant investment going on from the VC space. And I believe in looking at the top 50 startups for healthcare and life sciences, while number one, has a tremendous lead, a head start, that's China's, Ping An. There's over $1 billion of investment into Ping An, and they've got a pretty good advantage in terms of 1.4 billion population, and even just 15%, as registered users. That's 200 million people to collect data from. They've got a significant advantage, but within that top 50 of startups, a good 34 out of those 50 are in the US. And they're doing things on clinical decision support is one of the top use cases or areas where they're funding. Diagnostics, a big deal. I mean, as we can expect with computer vision, being able to take those data sets and do better diagnostics. Self-care and self-diagnosis. I think we've come a long way since the early days of WebMD. Where you put in your symptoms, and the joke from the WebMD folks was, well, no matter what you put in there, always an option was cancer. Well, we've come a lot further with the self-diagnosis here stuff now. And then as you get later on down the list, then you get to what's really important to pharma, which is drug discovery.
Yeah, and on the drug discovery side of things, I often find that there are a couple of ones that stand out just because they're new and novel. On the generative AI side of things, there's any number of biopharma, often startups, but even fairly established folks, which are looking into the use of things like transformer models, fine-tuning those on molecular data for going in and identifying compounds and potential proteins and peptides, and by fine-tuning these models with that real-world test data and doing this as part of an active learning loop, really accelerating that. But I also find folks going after fairly prosaic use cases by just enabling our researchers to go in and access the information that's at their fingertips, or that's really very difficult to go in and synthesize previously, leveraging these. But sometimes this can be a bit of a distraction. These are the icing on the cake. These are the ones that are shiny and most exciting. What I often find is that folks are really rethinking how they are working with their data and their data processes. How do we make the organization more data-driven? How do we go in and democratize that data, go in and provide access to that data, and go and make that the core of our processes? And I guess that brings us to the topic of data pipelines. Do you see folks going in and trying to accelerate data drug discovery by going in and rethinking their data pipelines and their data processes?
Yes, and that is a spot where I get asked to help. Thank you. There's things in drug discovery that are well beyond my comprehension, and your companies have guys with PhDs to go help and figure that out. But within the data pipelines, how the data flows from one spot to another, that's a spot where my company is positioned to help. And when I think about the early drug discovery pipeline, listen, it generally starts at the edge somewhere, within labs, taking an assay, taking one of the millions of drug compounds that your company may have, with one of the 100 million or so proteins that are part of the disease structure. taking that assay, getting it onto some massive scanner like an Opera Phoenix scanner, and starting to use that for building training sets. With that happening at the edge, and then later your training sets being developed perhaps in the core or in the cloud, well, that data's got to move somehow. And if you have intelligent data infrastructure, it's made a lot easier that those systems can then talk to one another and easily be replicated or cached between different systems so that that data can flow more freely versus a lot of times I'll see processes where, yeah, they're collecting that data and then later they're going to issue some job to do some copy. But with an intelligent data infrastructure, that can be done automatically. And the more that we help our folks automate within this process, generally the faster that entire pipeline can become.
I mean, I often think, well, we've often been talking about data silos in our industry, that we need to break down the data silos. But I feel like you're describing something which is a bit of an evolution for this. It's not just the data silos. We also have these infrastructure silos, and we have these tool silos, and we have all of these other people silos around the organization. And so it feels like it's a migration to recognizing that, well, we need to break down those silos across the life cycle of the analytics and machine learning and AI that we're trying to do? Or am I misinterpreting you?
No, I think it's an accurate interpretation, but it's not only across the life cycle, but pharma companies are great at doing collaboration, across continents, with CROs, with various, organizations, with researchers and institutions, and therefore being able to not only perhaps replicate that data in an efficient way and to do it securely, but as well to take perhaps copies of that data, efficient copies of that data, space-saving copies of that data, so that folks can work on separate pieces at separate times and then go and accelerate how those things come together to go build that pipeline.
Oh, absolutely. I mean, it's way easier said than done, though. So I'm curious as to the best practices. Are there things that you're seeing folks doing that really enable or sort of accelerating data-driven drug discovery? Is there a hit list, a cheat sheet of things that you can do in order to get started there?
Yeah. So again, I can speak to some of the things around the data and the data infrastructure. Obviously, I'm not one of the PhD researchers that may have some better things on those pieces of it. Certainly, if any of you went to GTC or look at the recordings, there was a presenter from Genentech who had shown what they had done for a specific use case, I believe it was E. coli based actually, where they had increased their candidates by 40x. So that's one more to contact as far as, or your researchers to contact as far as things that they're doing within the data science realm to get better results. That was impressive. I think all of you that are in pharma know just how important that drug discovery is to the company. That as folks would tell me, that it takes often about $2 billion, 10 to 12 years, and of course you've got patent lifetimes that are limited, but to bring a drug to market, the expense, the time, and anything that could be done to optimize that time, reduce that cost, or find better candidates are significant to the revenue generation of the company. But within the data pipeline, things that NetApp can help to help here. So as I looked at some pipelines of my customers, and like I said, stuff happening at the edge, stuff happening in the core, stuff happening in the cloud, but being able to bridge those together, whether it be tools like Domino's Nexus that can allow data scientists to collaborate and work, whether it be on-prem or in the cloud. NetApp helps enable making the data the same in both places. I think anybody who's been doing this work for a period of time or had researchers doing this work for a period of time has seen GPU scarcity in the cloud. Nodding heads here, yes, those P4D instances, especially in the US East, very tough to get anything on demand for those. So it may end up being more cost effective, or you may be able to process your pipelines faster with some on-prem GPUs. But you still may have some of that pipeline in the cloud, or vice versa. So something like Nexus that enables the data scientists to just share, to see that data wherever it is, and then it relies on NetApp technology behind the scenes to replicate that data efficiently or cache that data efficiently, so that it can be in both places, so that you can have your data scientists do work where it's most efficient and most cost-effective to go do that work.
But two things in what you were saying that I wanted to comment on. One of them was in terms of measuring value in terms of accelerating the drug discovery process. We had one of our customers, unfortunately won't go on record for saying it, but who was saying that, well, when you look at what that acceleration does in terms of bringing the drug to market faster, it was worth it for them to the tune of something like $1 to $2 billion. And so we talk about communicating the value of what we do, certainly to the degree that you can quantify how much you have accelerated your ability to get a particular drug to market. That is, the numbers become astronomical, and they become a great way of justifying all of the hard work that you are doing. The second thing I wanted to speak to was hybrid cloud. And it's always struck me that it feels like this is history repeating itself. I mean, we saw the migration from on-prem servers to cloud, to a recognition that we need hybrid cloud. On the storage side, both you and I have been in the storage industry back in the day, and I remember 2012, 2014, we were all about this transition in storage from on-prem to the cloud, to ultimately a recognition that, well, we need hybrid cloud that leverages the best of both worlds. And we've seen this in analytic databases, and it feels like this has now come into the world of analytics, machine learning, and AI. But with a bit of a different twist on it. So where we've gone from workloads that oftentimes were already in the cloud, and then folks are running into, okay, now actually we need to repatriate some of those workloads back on-prem because we don't have access to infrastructure, or because the costs are so high. And then to a recognition of, oh, okay, we need some sort of hybrid cloud that infrastructure. Are you seeing this again as being like historical inevitability, or is this one where, no, there are certain factors right now that are particularly driving hybrid?
Well, the historical nature, I used to have hair when I started this business, and I kind of remember there was mainframe to client server. There was consolidating, there was distributing, there's consolidating, there's distributing. There's plenty of that to go around, right? That is a part of this, perhaps. But I think it's fundamentally driven right now by speed and by money. Certainly, a lot of these AI projects will start in the cloud just because that infrastructure is there. I can get spun up right away. There's tools there. Let me go try something out. And the rolling out of super pods or base pods on-prem can take a good deal of time. I won't name names. I won't say how long it's taken some of my clients, but it's a process. It does take some time. You need to have plans for that. So I think both still have a use. Certainly getting those projects started, getting some value out of them right away, quite important to do in the cloud. But yes, when you start doing some cost analysis, sometimes it makes sense to bring those things back. And as we'd said, it aided by the fact that when you can't get the resources you want in the cloud, well, you've got to have them somewhere. I think one person had told me, data scientists aren't the most patient people. And it may be true, but they've got a job to do. They've got demands, and we want to make sure that we're giving them the tools and such they need to do their job. If there's scarcity of GPUs in the cloud, if we've got those on-prems, making those available, making it possible for them to do their job on-prem and perhaps at lower cost is advisable. And again, something like Domino's Nexus helping to bridge that gap so that the data scientists are working within the same toolkit that they're used to working in. And they don't even have to know whether it's on-prem or in the cloud. It's just, hey, that data is there. They can go get their jobs done.
Is there value in thinking about your jobs in terms of things like latency and cost or lumpiness and the ways that we would normally think about workloads, and going in and strategically assigning them to different environments based off of the profile of the environment? Or is this one where it's kind of a temporary phase that we're going through due to the scarcity or due to the organization and the legacy infrastructure that we need to work with?
Yeah, I don't think it's temporary because I've yet to find a client that says they have an unlimited budget. But I don't call on the federal government either. Maybe they would say that they do. But yeah, I've yet to find one that's unlimited with their money. So cost has always been an issue, will continue to be an issue. And you can do the math as far as whether it's cheaper for certain things to run them on-prem or in the cloud. And if you've got the flexibility to do both, then you've got the options. One particular pharma client, they've gone public in saying that the data needs to follow the compute, and that hybrid cloud, is their future. There's certainly a benefit to being able to have both from a cost and flexibility perspective.
Well, it always feels to me like you're always just one acquisition away from some sort of fragmentation in your ecosystem. But I guess touching on that cost point, so certainly there's an element of utilization. If you've got on-prem resources, go and increase utilization of those. Go in and presumably, similar to when we were talking about earlier during Nick's keynote about tracking those costs, there are FinOps capabilities that you would want in order to provide visibility into it. But are there other best practices for managing the cost of these workloads? Because it's one of those things where it's easy for us to be the victims of our own success. If we're really, really successful with all of this, then we will be spending a boatload more money on this.
Yeah. So listen, I'll give some very specific things I've found on some of the cloud workloads. If you've got, well, let's start this way. Last year I was at the Rev4 in New York City, and I watched one of the presentations, done by a pharma company about their aim to cut some costs in the cloud. And they focused a lot on compute things, and great as they should, and turning off instances that weren't in use, right-sizing instances. They didn't talk a lot about storage at that point in time. In doing some more work with them, come to find out that they were using Amazon's EFS for a large part of their Domino environment. Well, it turns out that was one of the most expensive cloud storage platforms that they could have possibly used. And had they had more intelligent data infrastructure, they could have taken advantage of things like tiering, that things that weren't in use would have been moved to a lower tier of storage. They could have taken advantage of things in intelligent data infrastructure of compression and deduplication. They would also have been able to take advantage of some space-saving snapshots instead of making these whole copies that they were doing. And then later, coming to find out, as they got pressure to cut costs, of the Domino environment storage, they had a number of places where they had duplicates, of data. The data scientists, in order to get their work done, had just created these full clones. So with some intelligent data infrastructure, we have some tools to be able to show, okay, these are data duplicates throughout your environment. You decide whether you need them or not, or whether you can, eliminate terabytes and terabytes of storage and just have them point to, one single source of truth. Also able to point out things of how long the data had not been accessed. I think everybody has a hard time. It was one of the keynotes here today too about data cleanliness, but more in terms of what I'm meaning is more in terms of getting your data scientist to clean up their environments, after they're done. Go ahead and delete that stuff that is not in use anymore, rather than letting it sit there and continue to incur charges. So with some intelligent data infrastructure, being able to quickly go and assess and see, okay, this pile of data hasn't been used in 2 years. This hasn't been used in a year. This hasn't been used in 90 days, 6 months, what have you. And then you can go ahead and make the educated decisions about at what point in time, you want to demand that those things get cleaned up.
Well, it sounds like there are a couple of key best practices there. One of them was the flexibility, so ensuring that you have the options, those lower cost options, or those more suitable options for a workload that you can go in and leverage. So, and presumably an area where you need to preserve that flexibility going forward, because obviously there are going to be new offerings here and we need a certain amount of agility to be able to take advantage of them. Yeah. There's another point which is then about the visibility into this. We need to be able to shine a light into the utilization of all of these. But that runs into the challenge of, okay, well, how do I shine a light into all of these different systems and how they're being used? That increases the complexity in that. And I guess that would mean then, well, you need a degree of integration across this in order to go in and provide that visibility into it and that ability to manage and optimize, but also that flexibility. Or is there like is there some way in which we can go in and overcome what seems to be an intrinsic challenge between the two of those?
Well, speaking for myself, my company, we have some tools that enable you to kind of look, point at any type of file share whatsoever and be able to get these types of metrics without seeing what the actual data is. Now, we're not violating any security issues here, but just based on metadata, being able to determine, again, the usage of it, whether there's duplicates of that data. So there's just some simple tools to be able to go and take advantage of that, which make a lot of sense to use, but maybe not everybody knows about that are there.
Well, I would think that data would also then help you in terms of optimizing process, so going in and understanding how much work was done on different projects and things like that. Are there other uses for that data that are really valuable for the enterprise?
Well, there's some other uses for the data in terms of being able to take a look at that metadata and being able to see if there's some compliance issues. Now, if we were in a financial services, session, we'd certainly be talking about social security numbers. Here in healthcare life sciences, patient identifiable information. Now, I know a lot of what my customers use is data that's already been cleansed, but this same tool would be able to help you to see if there are any issues in there in case you got something that wasn't cleansed or a different data set that you had developed, that you had brought forward that may have had some compliance issues. You want to get those things tagged before somebody else does, should there be an audit of some type.
Well, I mean, speaking of unauthorized access and usage of data, obviously I would think that, on the security side, this would have major implications as well. Can this also be an early warning system on the security side as well, breaches?
Not this one, but I'm glad you asked the question because with intelligent data infrastructure, there is an ability to protect yourself from the issue that, hey, listen, it's public. A guy had to testify before Congress at the beginning of the month. So most folks would know of Change Health and the breach that they had and the $22 million in ransom that they paid. I didn't see my customers directly, well, my payer provider customers certainly are affected by it and what they're going to do, but I didn't see pharma, customers affected by it. But I did see everyday people, neighbors who worked for healthcare providers, the doctors not getting paid, on time, prescriptions not being able to be filled in time. At any rate, if you've gotten to that point where they've accessed your data, yes, it's pretty late. They've already breached your perimeter. They've breached your network. They've breached user credentials to get to the data. But that's still not really an excuse to not protect that data. And again, if you have intelligent data infrastructure, you have some anomaly detection. So within, listen, I don't just work with my clients on AI things. NetApp internally does use AI within its storage arrays to go detect these anomalies. So we would have detected that a user that doesn't normally access certain file shares all of a sudden is accessing something. We would have detected, somebody who doesn't normally encrypt files is encrypting files. And we would have immediately taken an indelible snapshot of that data so that there was something to restore to so that you wouldn't have to pay millions and millions of dollars of ransom. And that feature is free within our operating environment. So if you are IT folks, you're going to talk to your IT folks, and if you do have NetApp infrastructure on-prem or in the cloud with AWS, FSxN or Azure NetApp Files or Google Cloud Volumes, whatever, it's probably something to ask your folks, hey, could we go ahead and turn this service on? It just doesn't seem worth the reputational risk to not have that protection.
Yeah, because normally there's always a hesitation on the part of most organizations to turn on telemetry for these systems. But it sounds like in this case it's well, yes, but if you don't turn on that telemetry, you're probably not collecting that information. You're probably not doing anomaly detection on that. You're likely going to be missing this.
Well, I think what I've seen in years of doing this in the storage space is anytime there's new new operating environments, every customer wants to put it through their paces. We've all got change control processes, and in big environments, you might do 1 or 2 major changes to your infrastructure a year. I'm just saying to plan, for that, and to get to a latest version that would enable, this feature, because it's just not worth the reputational risk, of having a ransomware attack and fine. And listen, the crooks are getting smarter and smarter. I mean, they're using AI to go and try and penetrate your defenses. So have a good defense, here as well.
Well, there's no way we can end on such a dour, downbeat note when it comes to security threats and challenges. Let's go back to the thing that's on everybody's mind, which is the Gen AI use cases. Obviously, we were talking about just briefly how some of these seem to be very, very high reward use cases, in the sense of if we are able to leverage transformers to accelerate that process and leverage these models in a quote-unquote generative fashion, incredible value there, but plenty of other opportunities around the organizations. Curious what you're seeing. Are there any really cool ones that other people should be trying to emulate?
Well, I can get to the cool ones in just a second, just because I can't not comment on one of the presentations we saw here, and she'd kind of ended with 2022 and ChatGPT released, and we've lived through this history, right? But to repeat it, it was November where ChatGPT was released. Within a week, they had 1 million users. Within 2 months, 100 million users. Faster than Instagram, Facebook, you name the company, faster than anybody getting that. And all of a sudden, now everybody had this ability to do some generative AI on their own. And then quickly, within corporations, it was, okay, what can we do with this? And 2023 kind of became the year of some pilots around this. So one of the first things was everybody realizing, okay, this isn't giving me correct answers with what we got. So it started with some RAG, retrieval augmented, generation, projects, and pointing at certain data within your company to get proper answers. And, RAG was great and worked, for a bit, and then all of a sudden you've got, over this last 12 months, all these new models, from Llama 3 and Falcon and Mistral and Mixtral, and name one a month, for crying out loud. So the pilots of this, where they were using cloud APIs, now all of a sudden it's, well, which API do I want to use now? There's a new model out there. So tough to keep up with. So NVIDIA's tried to simplify this. They announced at GTC the concept of a NIM, a containerized environment, like a Docker container that would kind of be that bridge between that and the cloud APIs. In terms of use cases that I've seen folks get good value at, we talk about within research, just being able to summarize some of those technical documents that I myself would never be able to read, right? Give me a 300-word summary of this so that the researcher can see whether they want to delve deeper into it. That is a good one. Seeing some internal things, people messing with chatbots, of course, and the like. But people getting to production has been a much more difficult challenge. And part of that is just the cost of using cloud APIs, tokens. I looked at one use case for one of my clients, and they've done some great work on this, and I've got to be kind of coy here on a recording of what the use case is, but when they got to looking at the cost model to go production and looking at GPT-4 tokens, the cost was going to be 8 figures. It was over $50 million in terms of its estimate, which kind of just threw things right back to kind of the very beginning of, do we want to just go ahead and invest in infrastructure and train models ourselves, on-prem, with our data? So I think that's why we haven't seen more of these things get into production yet, because for big companies, big life sciences companies, when we talk about doing this at scale, it could get quite expensive with tokens.
Well, it sounds like this is going back to our earlier point around workloads generally. So generative AI workloads aren't exempt from the laws of physics. And so when it comes to cost and latency, and so on. There probably is an aspect of being strategic around this as well. So there are presumably use cases where using a hosted third-party LLM makes the most sense, and there probably are use cases where you're going to go and need to host something internally using an open source LLM or maybe fine-tune there. But it's likely going to be not a one-size-fits-all approach, and as we get more mature, we're probably going to need to think about a more fractured or a broader Gen AI, a strategy for supporting Gen AI, much like we think about a broader strategy for AI and machine learning as a whole.
Indeed.
Richard, I've monopolized you with questions for far too long. We should open up to this incredible group. What would you like to find out? What questions do you have?
For those who couldn't hear, it's just a comment about more reasons for hybrid cloud or bringing things on-prem being access and security elements.
And scalability and the ability to go in and provide infrastructure on demand for when it's needed, and the productivity benefits that happen for, as you say, our data scientists aren't always the most patient of people.
Thank you for your comment.
Any other comments or vehement disagreements are also fine.
Yes, sir.
Yeah, when you talked earlier, you talked about the use case where you work with data scientists and you had to look at older data and you haven't touched this for a year or 2 years or whatever. Are you guys doing anything actively to kind of report on that to people so that they can clean that kind of stuff up? We see that all the time. We see that with many of our people. We have some active things going on right now with a couple different groups because of the cost of the storage.
Yeah, so the question was about data scientists and cleaning up their environments and stuff that's not used. And the question to me was, are we providing that information? Yes, we provide the tools to provide the information. So we'd provide tools to, say, the Domino administrator or somebody there within IT, R&D, IT, et cetera, to go be able to report on the environment, and then therefore go take that back to the data scientist or the data science leader or finance or whomever of where the usage was and what could be done to improve it. Does that answer your question?
On your own hardware.
Pardon?
Are they tools that are available for other tech hardware or just for yours?
Are they just for our own hardware? Well, they are free for our environments. I might have this edited off of the script here in a minute here, but if you are doing a migration to our environment, then you have access to these tools to go and evaluate those environments. And well, as one NetApp product manager said to me, who owns the product, he's like, hey, and with big pharma companies, those migrations could take years. Does that answer your question?
Sure does.
Yes, sir. Okay. So the question was about build versus buy, and do I foresee, I've just said seismic shift or a change, here and what may happen, that, hey, it's too complicated. The clients that I deal with are the very largest NetApp clients, in healthcare and life sciences. So in the space that I see, they've generally got talented IT staffs. They've got lots and lots of PhDs. They have the brain power to go and kind of roll these environments, out themselves. So in my space, I don't see that. But absolutely in some of these smaller companies, yeah, it can be way too much to take on. All right. Does that answer your question? Okay.
I I find myself usually giving the cop-out answer that it's never build versus buy, it's build and buy and hire. So it's depending on your particular use case that you're going after, whether or not there is an off-the-shelf solution that makes sense for you. What are the strategic considerations? Is this going to be core to your organization? Those examples that I was talking about of using an active learning approach to fine-tuning transformer models for protein and peptide treatments, that's not something that you would ever outsource to another organization. That is very, very core to your IP. So you can't. But when it comes to going in and being enabling your researchers to go in and access reports from multiple different sources faster, I mean, why wouldn't you be taking a look at that tool from Elsevier or LexisNexis that specifically goes after that? Now, for a lot of those, it's still early on in terms of the development of those tools, but you can kind of extrapolate out that, in a year or two, or maybe even just 6 months, they're going to get pretty far pretty quickly on those. And so for those ones, you can sort of make an educated guess early on that, okay, maybe I shouldn't invest in this because there's going to be something to buy. But there are plenty of, I would say the vast majority of use cases right now are still in that phase, especially on Gen AI, where you'd love to buy them. Everybody would love to buy them. That's why folks are hoping that OpenAI's models are going to be able to solve all this, because maybe I can buy that and just connect that at the end of a data pipeline and we're going to be good. And we all know, yeah, a lot of that isn't really going to work.
I want to add one more thing, though, to your question there. I did see some struggle to create a like-for-like environment on-prem. And what I mean by that is not in terms of the infrastructure. Hey, NVIDIA GPUs in the cloud and NVIDIA GPUs on-prem. I mean, NetApp, ONTAP in FSXN, NetApp ONTAP, on-prem. But in terms of the cost modeling, of creating that type of pay-per-use model. And I did see, one of the companies working with, they struggled to with it for a while, but eventually they got it right, and with the help of the business, so what they were used to paying in order to make it very much like for like. So again, there is work to do in that operational model. But again, most of my clients being so large have the capacity to figure it out.
Yeah. Well, thank you everybody for joining us here. Please do reach out to Richard with further questions. I'll myself. Richard, thank you so much for joining us.
All right. Thanks for having me.